Alright, today we are starting chapter 3, and 3.1 is solving linear equations by graphing and using tables. So a linear equation is an equation between two variables, typically x and y, that when we graph it, it gives us a straight line. So no curves or anything. So you might see y equals mx plus b, that's our basic slope-intercept form. Y minus y1 equals m times x minus x1, that's our point-slope form, which when we reduce turns us into slope-intercept form. And lastly, standard form, we have ax plus by equals c. Again, all of these are raised to the first power, so they will give us a straight line. So a system of equations is a set of equations, so just more than one. It could be 2, 3, 4, so on and so forth. And then for this, we are looking for a common solution, meaning we are looking for a solution that satisfies all of the equations. So a linear system is just multiple linear equations grouped together. So if we are given two lines and we want to figure out what do they have in common, we are trying to figure out where do the lines intersect. So for these first couple, we're giving you a point. The first one is 2, 4. So we're going to see if this is a point on both of these lines. If it is, that's where these lines will intersect, and that will be our common solution. So to start, I'm just going to plug 2 in for x and 4 in for y, and see if we get -6 for the first equation. So 2 for x minus 2 times y, so that'll give us 2 minus 8, which indeed gives us -6. So first one's good to go. Now plugging it into the second equation, we want to see if that one's true as well. So plug in 2 for x plus 4 for y. That gives us 4 plus 4, which is in fact 8. So that tells us that yes, 2, 4 is a point on both of those lines, which means it is a solution. So you could go to the point 2, 4 on a graph, and you would be on both of those lines. All right, so let's check the next one. This time we're checking 3, 2. So plug in 3 for x and 2 for y. That gives us 6 plus 6, which equals 12, which is what we said it is. So we know that that point's on the first line. Now let's check for the second line. So 8 times 3 minus 6 times 2. That gives us 24 minus 12, which is 12, which is not 24 with what we said. So that means the point 3, 2 is not on the second line. So no, that point is not a solution. All right, so those two are just checking to see if those given points lied on both of those equations. All right, next we're going to see checking for our solutions by using a table. All right, so here maybe I want to rearrange this my equation and get y by itself. If I do that, I might end up with y equals -x plus 4. So if I plug in plug in a 1, I get -1 plus 4, which is 3. If I plug in 2, -2 plus 4, which is 2. Plug in 3, I get -3 plus 4, which is 1. Plug in 4, I get -4 plus 4, which is 0. So let's go to my graph. 1, 3, 2, 2, 3, 1, 4, 0. So that's the first line. Now if I want to do the same thing to the second equation, maybe I add 2y to both sides and subtract 4. So 2y equals x minus 4. Divide by 2, y equals 1/2 x minus 2. So if I plug in 1, I get an answer of -1.5. If I plug in 2, I get an answer of -1. If I plug in 3, I get an answer of -0.5. And if I plug in 4, I get an answer of 0. All right, now these aren't going to fit perfectly on our graph. All right, but what we do see is that we might have a common point already. So I'll just graph these quickly, or estimate them roughly. So something like that. So if we were looking for our intersection point, right there. Or if we look on our graph, if we plug in 4, we get an output of 0 in both of our equations. So that's the point that would work for both. So our solution, is 4, 0. All right, so we already have them as set for y equals. So y equals, we said negative x plus 4, and we had y equals 1/2 x minus 2. So we could have graphed both of those lines and found the intersection point, which is what we did. So when will these two equations be equal to one another? When x equals 4, to give us a solution of 4, 0. So that point is on both of those lines. That is my solution to that system. All right, next page. All right, you and your friend decide you want to spend the afternoon on kayaks down the river. So you find one rental service that charges $2 per hour with no charge for the paddle. So if I want to represent that, maybe I'll just go number 1. I could say y equals 2x. So $2 for every hour with no charge for the paddle. Your friend, on the other hand, found a service that is $1 per hour. So y equals 1x, but charges $5 for the paddle. So I need to add on an additional $5 right away. So now I can graph both of these lines. So y equals 2x has an intercept of 0 and a slope of 2. So rise over run, up 2 over 1. I have my line. And y equals 1x plus 5 is my second line. So starting at the intercept of 5, slope of 1, so up 1 over 1. All right, so the slower the line, the cheaper it is. So it looks like the red line is cheaper. So that would mean the $2 per hour. All right, but how long is it cheaper for? Well, let's see. Let's go to our graph, and we want to find the intersection point. Now, maybe you can see that. It's going to be right there. It's just circled in green. So $2 per hour is cheaper until we look down at how long that was, and we see 5 hours. All right, so until 5 hours, then they're the same price. After 5 hours, the cheaper service is going to be the $1 an hour with $5 per paddle. All right, so $2 an hour is cheaper until 5 hours. That's where they intersect. And then the blue line is lower, so that was our friend's service. That's $1 an hour with a $5 charge for the paddle. So depending on how long you use the kayaks, you might want to choose a different service. All right, for our next problem, we're talking about gym memberships. So you decide to go and buy a gym membership. When you get to the counter, the attendant offers you a choice. So first choice, choice number 1, it's going to be a fee of $250 a month, and that's it. So if I were to write that as an equation, I could say y equals, which is my final amount, 250 times x, so $250 per month. And then the other option, so choice number 2, is a flat fee of $3,000 a year. So that one doesn't depend on any months, so I'm not going to have an x. That's just going to be y equals 3,000. So that y equals 3,000 is actually pretty easy to graph. It's just going to be a horizontal line at 3,000. All right, because that price never goes up, never goes down. Whether that's you have or use a membership for 1 month or 12, it's still $3,000. Now, if I want to go the $250 a month, all right, I could go up 250 over 1, up 250 over 2. All right, so if we have our red line graphed and we want to look at our intersection point, let's circle it in green. And so we see that it occurs up at $3,000, but we want to figure out how long that takes. So I'm going to look down at the x-axis, which looks like it's down at around 12. So what does that mean? Looks like the red line for the $250 a month is going to be cheaper until you hit 12 months. So if you're talking about a yearly fee, it doesn't really matter. It's going to be the same price per 12 months. All right, that's going to be $3,000. So if you're going yearly, it doesn't matter which one you choose, but maybe you don't want to make that commitment for a full year, so it might be better for you to take the $250 a month instead. All right, now let's write the equations of some of these lines. So moving down below, first I'll start with the negative slope, and I see it has a slope of -1, so y equals -x, and the intercept is at -2, so y equals -x minus 2. The positive slope line has a slope of 4, so y equals 4x, and an intercept of 3, so we get 4x plus 3. Moving on to the next one, let's start with the horizontal line. That's just going to be y equals -1. And the second line, I see that has a slope of down 5 over 2, so y equals -5/2 x plus 4 for the intercept. Lastly, the negative slope is a -1/2, so y equals -1/2 x, and that has an intercept of 3, so plus 3. Then I have y equals, that has, the last one has a slope of 3, so 3x minus 4, because that y-intercept is down 4. All right, so there's our second page of notes. We only got one more, and we're all done. All right, so the last thing we need to do today is talk about our systems and how many solutions they have, so we are classifying them. If a system is independent usually meaning alone, so that means an independent system only has one solution. Or one intersection point. All right, if it's dependent, that means the solutions depend on both of the equations. So that's where both of the equations are going to look exactly the same. So if it's the same equation, it's like both lines are on top of one another, so where do they touch? Well, if it's the same equation, they're always touching, so that would mean infinite solutions. If you have the same equation and you plug in a point that works for one, it's got to work for both since they're identical. And lastly, we just have consistent versus inconsistent. So if we are consistent, that means you at least have one solution. All right, so if you can find at least one solution, it's consistent. Inconsistent has no solutions. So if there's no solutions, that means the lines never touch. And if lines never touch, that tells us that they are parallel. So an independent, consistent solution is going to be, the lines are going to be two separate equations, so two different equations with one intersection point. Dependent means you have the same equations, so the lines are always touching. And if you have parallel lines, so same slope but different intercepts, those will never touch, so that is inconsistent with no solution. So a couple more. We want to classify it as dependent or independent and determine the number of solutions. So I'm going to solve both of these equations for y. So the first one, I'll subtract the 2x, so I get y equals negative 2x plus 3. The second one, maybe I will subtract 9, so negative 3y equals 6x minus 9. Divide by negative 3, we get y equals negative 2x plus 3. So negative 2x plus 3 and negative 2x plus 3, same equation. All right, so that's going to be dependent and consistent infinite solutions, because that is the same exact line. So one of them is just on top of the other. If you go to the next question, maybe I subtract 3x, so I get y equals negative 3x plus 3. And if I subtract 2 over on the second equation, I get y equals negative 3x plus 2. So same slope, but different intercepts. So these are parallel lines, meaning they will never touch. If they don't touch, we don't have a solution. All right, so no solution means inconsistent and no solution. All right, last one. Buck Hill charges $28 for a full ski rental, as well as $56 for private lessons. Afton Alps charges $32 for a full ski rental, but only $54 per hour for private lessons. So first off, let's write equations for both of these. So for Buck Hill, I'm going to say y equals, now the thing that depends on something is going to be the lessons. Regardless of how long you take lessons for, the ski rental is still $28. So that means it's going to be $56 per hour, where x is the number of hours, plus 28 additional dollars. If I do that for Afton, I'm going to get y equals 54x plus 32. So we want to figure out when they're paying the same amount. So can we agree that y is equal to y? So if we can agree with that, then I'm going to plug in 56x plus 28 for one side of y and 54x plus 32 for the other side to equal y. So 56x plus 28 equals 54x plus 32. So now I just want to solve for x. So get them on the same side of the equation. We get 2x plus 28 equals 32. If I subtract 28 on both sides, 2x equals 4. So we get that x equals 2. Now we said at the beginning that x represents the number of hours. So how many hours of private lessons are needed until you are paying the same amount? That's going to be 2 hours.